All right, so we just finished example 1, so we tried examples 2, 3, and 4. So let's go through our answers here. All right, so who are the states? Remember, states are the who. So in this example, who is receiving stuff? It's going to be the grade levels. Grade levels. First, second, third, fourth, fifth grade. Grade levels. All right, who is my population? Okay. What is stuff getting broken up by? And it's getting broken up by what? The number of students. And then last but not least, what are my seats? Okay. What is given out? What are getting the seats? Those would be the teachers. The teachers is what's given out. So many teachers will teach first grade, so many teachers, so on and so forth. All right. Let's look at example 3. There are 75 administrative assistants for the entire college, which has 10 academic departments. Each department will receive assistants based on the number of students that have declared the department as a major. So what are my states in this case? All right. Who are the players involved? All right. My states, once again, would be your all right, so the states, the who is the 10 departments. Okay. The population, how is it getting broke up again? By the number of students in each department. And then the seats, the what is given out would be the assistants. Okay. And then last but not least, let's look at example 4. The city is planning to reorganize 5 major bus routes around the city. The average number of passengers on each route would determine how the city's 36 buses will be apportioned. Okay. So what are my states? So my states would be the 5 bus routes. Okay. My population is determined based on the number of passengers. And so my seats would be the buses. How many buses are put onto each route? Okay. So that's just some practice on who the states are, what the seats are, and how it's determined, which would be your population. All right, so some ratios that we're going to use to determine some of our apportionments are as follows. One is going to be what we call the standard divisor, or the SD, and that is the ratio of the total population to the seats. So my SD is going to be the total population over the number of seats that we have. So population over seats, and they're using the letter M for seats. Okay. That is how we find our standard divisor. And then the standard divisor represents the number of people per one seat. Okay. So if you think about it, we kind of did that back with our candy problems or our DVD problems. Okay. We said, well, then for how many points earned on a test would a student earn 1 DVD? So if you think about it, we have 360 points, and we had how many? It was 60 DVDs. So if we divided those out, 360 divided by 60, well, 36 divided by 6 would be 6 points. Okay. So for every 6 points that a kid gets, they should get one. They should have gotten one CD. Okay. So for every 6 points, they got one CD. That would be what they would be an example of what they were talking about when it came to our standard divisor. All right. The standard divisor represents the number of people or population unit per one seat. Okay. And like I said, they'll always think about people, just like on this example, it was points. So 6 points for one CD, it'd be whatever it is per one seat. All right. And then your standard quotas, all right, this is another one that we would use, is the ratio of the state population to the standard divisor. So if I want to find my quota, so Q, that is the state population, not the total, over the standard divisor. Okay. So it's the state population over the standard divisor. Okay. And that, you can see they're using lowercase p to represent each individual state. All right. So it's the state population over the standard divisor. All right. And your standard quota represents the exact number, including decimal, of seats that each state should get if one seat should be divided into smaller parts. Okay? All right. Questions there? All right, so moving right along. So if you notice what we have to do, so first off, we need to figure out what our standard, so let's look at example 3. Consider a nation of 6 states with only 250 seats in their Congress with different populations. Okay? So they want to know how many seats should they receive. All right? And so the first thing we need to do is we need to find the standard divisor. And how do we say that was again? Remember, your standard divisor was the total population divided by the number of seats. So in this case, my total population, 12,500,000 out of the total number of seats, which was 250 seats. And so when I do my math there, 12,500,000, 12,500,000 divided by 250 seats, I get 50,000 is my standard divisor. Okay? And so now let us find our standard quota. And so what did we say the quota was? The quota was that the state population, so in this case for A would be 1,646,000 divided by our standard divisor. And so if we do, for this one, if we do our 1,646,000 divided by 50,000, I'm going to get that my standard quota is 32.92. Okay. All right. And so basically we're going to kind of work our way through the rest of them. So 6,936,000 divided by 50,000 gives me 138.72. Okay. And then same thing, 154 divided by 50,000 would be 3.08. The 2 million divided by 50,000 is 41.82. The 685 divided by 50,000 is 13.70. And then our 988 divided by 50,000 is 19.76. And if we add all those up, we should get our 250, okay, for our total. Because we knew we had 250 seats, so that makes sense. But now, once again, if you think about, and this is kind of where we're going to get to eventually, but if you think about what we're saying here, I can't give out a half a seat, okay? Or I can't give out a 0.9 of a seat. So what if we just use our normal rounding rules, okay? Let's, by chance, say, let's just use our normal rounding rules. So they actually would say 0.9 would round up, 0.7 would round up, so that'd be 139. 0.0 would not round, so it'd stay at 3. 41.8 would round up, so 42. 0.7 would be 14. 19 would round up to 20. Okay, so now if we add all those numbers together, 33 plus 139 plus 3 plus 42 plus 14 plus 20, we get 251. Well, there's only 250 seats in our Congress, so we're going to have a problem. And that's kind of what this unit's all about. So there's different people that came up with different ways to solve this problem. And once again, you think about it, tying into last week, getting that fair share. Okay, so questions there. All right, so that's kind of what we're going to do there. All right, so some special roundings of quotas. Okay, so if you talk about the normal rule, that's just your normal 0.5 rule. So if it's above 0.5, it rounds up. If it's below 0.5, it rounds down. Okay, that's like your normal rounding rules. All right, so there are going to be some special rounding of quotas that we talk about. And two of them are the upper quota. And basically what the upper quota says that is if it is anything above 45. So it could be 45.01. That's still above 45. And if that's the case, if there's a decimal at all, you round up. So 45.6, obviously, by just general rounding rules, you'd say rounds up to 46. But 9.2, normally you would keep it 9. But if we're doing the upper quota, I want you to go ahead and round up. If it's bigger than 9, go ahead and round up. Bigger than 17, so go ahead and round up to 18. Now this is right on the money, so we actually, our upper quota would just stay that same number. All right, so my logic then would be the same. So upper quota, if it's anything bigger than that number, round up. Okay, so what do you think the lower quota is? If it's bigger than that number, you're still going to round down. So even though this is 35.6, by traditional rounding rules, we would round up. But on this one, we are actually going to keep it at 35. Round down, so this would stay at 99. Round down, this would stay at 16. And because it's right on the money, this actually is going to stay. All right. Questions there? All right. All right. So now what they want us to do is go back to the example that we just did. Okay. They want us to go back to the example that we just did with our 6 countries or nations. and do the